So far, we have been thinking about how to come up with a construction of real exchange rates based on nominal exchange rates. And this was an important element for us to consider, especially when we were thinking about the choice between purchasing domestic goods versus foreign goods, right? But we haven't yet answered about the question about where do exactly these nominal exchange rates come in from and what are the factors that determine it. So to understand these things a bit more, we would actually need to look at the another dimension of this openness that we have been talking about, namely the choice of investor between actually purchasing domestic assets versus financial foreign assets, right? So we are going to now think about this investors problem, right? Who are thinking about whether to hold domestic assets or foreign assets. And just to make things simple, let's consider the choice between a domestic and foreign 1 year bond, uh, which is a safe bond. Okay. So first, suppose that one decides to hold domestic bonds. Then IT denotes the interest rate on the domestic bonds. Then 1 unit of domestic currency invested in the domestic bond is going to give us 1 plus IT units of domestic currency next year, right? And similarly, if you had 1 unit of foreign currency and you had invested it, then you would get some interest rate, right? Now, the question is it enough to just look at the interest rates being offered by these different assets when thinking about whether we want to hold domestic assets or foreign assets? The answer we'll see is that's not going to be sufficient. We also need to look at what's going to be the exchange rate that is going to prevail not just today, but also 1 year later. And bringing all of these things together will give us a theory of how we will expect the exchange rates to be related to the interest rates, right? So this helps to connect two of the different prices or things that we have been discussing so far, right? Exchange rates and interest rates. And we are going to also be using an argument that you have seen before. So we are going to be thinking in terms of arbitrage implications in terms of this market. Okay. So let's then continue with our discussion. So we have already looked at what happens if you decide to hold a domestic 1 year bond. Then 1 unit of domestic currency is going to be worth 1 plus IT units of domestic currency next year. Now, what happens instead if you are going to invest in this foreign bond? Well, the first thing to do is that you have to convert the domestic currency that you have into foreign currency today. So 1 unit of domestic currency is going to be equal to ET amount of foreign currency today, where ET is the current exchange rate, right? So this is the nominal exchange rate. Now, once you have got ET units of foreign currency, you can actually invest that into bonds. And remember, each unit of foreign bond for each unit of foreign currency that you have is going to give you 1 plus I star T amount of foreign currency next period, right? So if you have got ET units of foreign currency, which you're going to invest in foreign bonds, that is going to give you ET into 1 plus I star T units of foreign currency next year, right? But we want to compare this amount with the amount of domestic currency that we have next year, right? So we need to again convert the foreign currency next year into domestic currency next year, right? So how do we do that? Well, we need to figure out what's going to be the exchange rate next period, right? So suppose that we expect the next year's exchange rate to be ET plus 1. This is the exchange rate that we expect to prevail. Then ET into 1 plus I star T units of foreign currency next year will be equivalent to ET into 1 plus I star T divided by this ET plus 1 E units of domestic currency next year, right? So what it tells you again is that it's not just enough to compare IT and IT star, right? What we need to compare is this 1 plus IT versus this expression that you see here, right? So this tells us that we need to also figure out what's the current exchange rate as well as what's the future expected, right? Now, suppose that you have got investors who only care about the expected rate of return and want to only hold the asset with the highest expected rate of return, right? So in other words, these are risk neutral investors, right? So if you've got risk neutral investors, then arbitrage is going to imply that you're going to have the following relationship holding true, right? 1 plus IT is equal to ET into 1 plus I star T divided by ET plus 1E, right? Now, why is this true? So suppose this was not true. Suppose that you had 1 plus IT is going to be strictly greater than this expression on the right-hand side. Then definitely the investors would want to just hold the domestic asset, right? And as a result of that, the price of this domestic asset is going to go up, and hence the interest rate would actually fall. Or if you have got that the right-hand side is greater, then there's going to be much more demand for the foreign assets, right? And as a result of that, again, the exchange rates you would expect would be adjusting and so on, right? So till you have that this equality holding true, right? So this equality is important, and this relationship between the nominal interest rate, foreign nominal interest rate, and the exchange rate is known as the interest parity condition. And in fact, this is the uncovered version of the interest parity condition, right? So there is another version of the interest parity condition, which we might see sometime later. Okay, before we look at the implications of this interest rate parity condition, there are two things to note that we have used a few strong assumptions in deriving this, right? So one, we assume that there are no transaction costs. So what are the different transactions costs that would have occurred? Remember, we are making a lot of different transactions, right? We first exchanged the domestic currency for the foreign currency. Then we are actually buying foreign bonds, right? Then we are selling the foreign bonds, and then we are again converting it back, right? So every time, if you actually in real world, you have transaction costs associated with each of these transactions, in the sense that they do not come for free. So then that would be something that you might have to actually take into account when you're thinking of using this formula in real world, right? But for making the conceptual point, we can safely ignore this for the moment, right? The other thing that we did in our analysis is that we basically are looking at things from a risk neutral perspective. And so we were okay with just saying that, this is the expected interest rate that's going to prevail next period, right? But in reality, of course, there is uncertainty about what's going to be the expected interest rate, right? So we know what's the domestic interest rate, we know what's the foreign interest rate this period, we know what's the exchange rate today, but this is the where the uncertainty comes in, right? And because we were thinking about it from a risk neutral perspective, we were okay with just looking at expected value of this thing. But of course, if you are looking at it from a, let's say, a risk averse investor's perspective, then just this information is not going to be enough, right? So you would expect that because foreign bonds are more risky than holding domestic bonds, then investors might want a risk premium on top of this return that they're getting in order to hold the foreign bond, right? So that is something again that we have abstracted away from. Okay, so having said that, let's work with these two conditions. So first, note that we can rewrite the interest parity condition as follows. So this is the interest parity condition that we had. What we want to do is divide by ET on both sides. So we end up getting that you have got the denominator here is ET plus 1 by ET, and then we are adding and subtracting ET from both sides, right? So if you simplify this expression that you see in the denominator, this is just ET plus 1 by ET minus 1 plus 1. So minus 1 and plus 1 cancels out, and then you end up getting the same expression. So what's the advantage of writing this in this format? Well, this basically gives us a relationship between the domestic interest rate, which is this term, the current exchange rate, which is this term, the foreign interest rate, which is this term, plus in the denominator, you have now this term, which is nothing but the expected rate of appreciation of the domestic currency, right? So this is the percentage change in the value of the exchange rate of the currency, and hence this is the relationship, right? If these interest rates and expected rates of appreciation of domestic currency are not too large, often an approximation is used, which is that the nominal interest rate is equal to the foreign interest rate minus the expected rate of appreciation of the currency. And you get this relationship by multiplying this 1 plus IT by this term here, and then just ignoring the second order terms, right? So if you do that, you end up getting this relationship. Actually, there's one small typo in the expression here. This ET should not be in the numerator, right? So I'll correct it when I post the slides. Okay, so this is the relationship that you end up getting, and this relationship is just saying that the domestic interest rate approximately equals the foreign interest rate minus the expected rate of appreciation. Okay. All right. So let's look at the implication of this. Suppose that 1 year nominal interest rate is 1% in the domestic country and 5% in the foreign country. So if we were just to look at the interest rates, then one might conclude that it doesn't make sense to hold the domestic asset. One should be holding the foreign interest rate, right? But what we have learned from our discussion so far is that it's not just enough to compare the interest rates. We also should look at what we expect to be happening to the currency, right? So if the currency, for example, is expected to appreciate by more than 4%, then one should actually be holding the domestic bond, right? Otherwise, we should be holding the foreign bond. So this expected rate of appreciation of the currency is something that we should also take into account, right? There's another way of thinking about this, that suppose that you go and see that this is the rate that is prevailing, right, in the different countries, right? And capital is free to move between the different countries, right? So all the assumptions that we have made in the uncovered interest parity condition holds, then it must be the case that investors are expecting that on average, there's going to be an appreciation of domestic currency relative to the foreign currency by about 4%. And that is why they're willing to hold their domestic bonds despite the lower interest rate that the domestic bonds are giving, right? So that's one way of thinking about the implication of this. Okay, so what are the other implications? Well, one thing that you note is that this relationship that we see here, this actually ends up tying the interest rates between the two countries and the exchange rates, right? So there are implications of this also, that, for instance, unless you are willing to tolerate large changes in the exchange rate, then that must mean that domestic and foreign interest rates are likely to move together, right? So that's why you would often see that if you have got changes in the interest rate in, let's say, the United States, typically that is often followed by changes in the interest rate all over the world, right? And in the extreme case where you have got that countries have committed to maintaining the bilateral exchange rate at a fixed value, then in that case, the market will want the exchange rates to remain constant and the expected depreciation rate is going to be equal to zero. If that is the case, from here you get that the two interest rates in the two countries must also be exactly moving together, right? Now, in reality, of course, no governments usually constrain their policies so much, in the sense that they are okay with exchange rates moving around a bit. But they would still want to not have too high changes in exchange rates. And as a result of that, that means that interest rates across different countries can only vary by so much, right? Compared to the changes in the exchange rate that you see, right? We can also actually use this interest parity condition, which we have discussed in terms of nominal interest rate and the exchange rates, to talk also about the relationship between the real interest rate and the real exchange rate. And that would also allow you to recap some of the formulas that we have seen. So remember that this was the relationship between the real interest rate and the nominal interest rate and the expected inflation. We can apply the same relationship, but now to the foreign variables. So here RT is the domestic interest rate. So R star T is the foreign interest rate. Similarly, IT is the nominal interest rate. I star T is the foreign nominal interest rate. And pi T plus 1 E is the expected inflation in the domestic economy. And pi star ET plus 1 is the inflation that is expected in the foreign economy, right? So we had the basic version of the interest parity conditions in this way. What we want instead of this is that we want a relationship in terms of, not in terms of I, but in terms of R. And instead of the nominal exchange rate, we want the real interest rate, right? The question is, what's the relationship that we would get? Well, the idea is that we have to apply these relationships one by one. So applying these two formulas to the uncovered interest parity condition, which is this. Now, suppose that we want to replace this 1 plus IT in terms of this 1 plus RT that we had, right? So we can easily do that. Instead of 1 plus IT, if you write 1 plus RT times 1 plus pi ET plus 1, and similarly 1 plus I star T is replaced by corresponding terms in the foreign real interest rate and the foreign inflation, you will end up with a relationship which looks like this, right? So this has made progress in the sense that at least we have got rid of the nominal interest rates, but we still have the nominal exchange rates and the inflation rate. So we want to go from here somehow to the real exchange rate, right? So let's see how we can do that. So remember that the definition of inflation is that this is the change in the price level. So therefore, the definition of expected inflation rate is the change in the expected price level, right? So 1 plus pi et plus 1 would be equal to PET plus 1 by PT, right? So we can substitute out this expression for 1 plus pi et 1 and 1 plus pi et plus 1 from here. And we end up getting this expression that you see here, right? So the final change that you have to do is to remember the definition of real exchange rate, which is this epsilon was equal to EP by P star. And if you now use that and simplify these terms that you see the last three terms on the right hand side, you end up with the following relation, right? The real exchange rate is going to be 1 plus RT times 1 plus R star T by this expected real interest, right? So the real exchange rate today, which is this term, depends on the domestic and foreign real exchange rates. So this is the RT and R star T, and it also depends on the exchange rate that we expect to prevail in the future, right? The real exchange rate that we expect to prevail in the future. So that's the relationship. And if you want to take a deeper look at some of these concepts, this is the reference that we have been using for our discussion of exchange rates. So you are free to look up some more exercises and discussions related to these concepts there, for instance.